today, the diesel engine is a kind of all-rounder. So starting here from the light commercial vehicle up to the heavy-duty vehicles, but this will change on our way to a carbon-neutral mobility. And if we look for the carbon-neutral mobility, there will be no solution, one-fits-all solution. And this is the part where the hydrogen engine is a complementary CO2 neutral technology. And if we compare these different CO2 neutral technologies like battery vehicle, fuel cell, and the hydrogen engine, you could find a place for the battery electric vehicle, commercial vehicle, for the fuel cell, but also for the hydrogen engine. And it is a mandatory technology. So our plan is to prepare the component that they are ready in the range of 2025. And if we are talking about component, this is then the whole component set. This is not only the injector, this is the key component, the hydrogen injector for the hydrogen engine, but we need also other components like we know already today, the ECU, the control unit, and all the other components. But 2025 in this range, we will be ready for our components.
We've been a business for 21 years developing fuel cells, and that's, we're one of the longest existing companies in the world developing fuel cells. And I think it's now got to the point where, we've been there telling people how the benefits of the technology and how it can support this transition to zero emissions for a long time. And now we're really feeling that the wind is changing and there's an understanding of how fuel cells are a key part of decarbonising vehicles, and particularly in the area of heavy duty and commercial vehicles. Working with our products you can probably see behind, our IE Drive fuel cell products, which are two variants. We have the heavy duty version, and that's specifically designed to go in buses and trucks. And then we also do the P100 version, which is the fuel cell engine will be put into a car with Changan. So working with Changan in the UK and putting our fuel cell engine into their cars to test as well.
It's great to be here with Electra. It's our very first show, our very first. So it's a big thing for us, and I think it's a big thing for the market to see exactly who we are and what we've achieved. We were the first to put fleets of electric HGVs onto UK roads. So the vehicle behind us, the 19-ton refrigerated vehicle, is fully zero emissions, of course, that's the biggest thing. It's actually going into operation with Sainsbury's. They're going to operate it for 3 months, and that's going to give us the data that we need to design and spec the future builds that we're doing next year.
Our technology has been around for a while. We've been developing it since 2011, and the technology is there to allow us to transition from diesel through to zero emissions. So we use the existing diesel engine and we add a hydrogen system to it, and we displace diesel with hydrogen. And we do that working with the OEM to get the maximum hydrogen to diesel ratio we can achieve. And in some applications, we're achieving over 70 to 80% hydrogen in use. But the truck is a development program. We're just finishing the pilot build of the 5 pre-production prototypes. That's the last prototype before we go to a production build. We have to transition, and this technology is a transition technology, and that's where this technology really comes into play.
So this is a fuel cell that's designed for this heavy-duty use. It's been designed and proven out actually in lots of buses around the UK already in tens of thousands of hours. So it suits this hard-working application. And then we've got an amount of energy on board in hydrogen, which is enabling these vehicles to do a really hard day job. So it's twice the energy you'd get in an equivalent battery electric vehicle, which means that those longer duty cycles, those harder working vehicles, every day on a bin lorry, out collecting the bins, working really hard, and it's a vehicle that would do the job and just keep doing that job. Our next step is to do a fleet. So yeah, proving things out at that scale of a fleet, both the infrastructure and the vehicles, getting it into the hands of real users like Glasgow, who are partners on this project, and so that the drivers, the end users, the fleet managers can get a sense of what this technology looks like at that scale and how then it's deployed to solve all of these problems of both decarbonisation, air quality and net zero.
We have our hydrogen fuel cell vehicle, which is called Mirai, on show today, and we really see this as a game-changing technology. We really believe that this is a technology for the future, technology for now as well, actually. Hydrogen fuel cell vehicle that we have, it can be filled in a matter of a few minutes, and it has a 400+ mile range, really attractive, and it really does offer a solution for a new future technology going forwards.
So the ambulance itself is a hydrogen fuel cell range extension to a battery electric ambulance. But what we've actually done is approached from a whole vehicle perspective, how do you do the ambulance of the future? The challenge in an ambulance context to be zero emission is that you need quite a lot of power to keep the heating on, to be ready to go when the ambulance wants to go. And when you look at what could you do with battery technology with that, there's a limited number of examples where those could be done with battery alone. So by having the hydrogen fuel cell to provide the range extension, the vehicle can fuel in 5 minutes like they used to. The weight and everything behind the vehicle still is the same as what we have in the current ambulance system. You can keep it hot, etc., etc. So effectively, battery technology for zero emission won't be able to do it, whereas the combination with hydrogen and battery technology can provide an ambulance that will be fit for the future. We're going to have it actually on the streets of London ambulance taking patients. So it is a fully working ambulance inside, and we've done that from scratch. We are hoping to show that a significant proportion of the London ambulance service could go to zero emission before 2030.